All right, so Doug, we're going to go ahead and get started.
No, we're not.
So I've got a few intro slides, based on the people in the room and the people that I've noticed online. I don't know that a whole lot of introduction is necessary to CableLabs and the SCTE, but we'll go through it anyway. We're here up in CableLabs in Louisville, and some of the folks did not make it up here, and I can see why. It looks like I've got some trees down in my yard and some pretty bad storms on the south side. So
got to shovel your driveway.
you got to shovel the driveway. Yeah, buy a chainsaw. Anyway, so for those of you that don't know me, I'm Randy Westrick. I'm with CableLabs, which is the parent company of SCTE, as well as Kyrio, and I'll go through some of that. But welcome to the last Thursday series. Today we've got Doug Jones to talk about DOCSIS 4.0.
That was an applause line.
I think it'll be educational for everybody. So let me go. Okay, now my slides aren't working.
Are you sharing your slides later?
Yeah.
Nothing proprietary.
Okay. Let's see. Oh, that I think maybe I hit the wrong button.
Very little correct.
So I do want to, I'll talk a little bit about the benefits of SCTE and all access, but I do want to remind everybody, we've had a busy week here with the Rocky Mountain chapter. We had a mixer and cable games on Tuesday night. We had the golf tournament yesterday. It was well attended, and fortunately the weather cooperated for that. And then today we're having the last Thursday with Doug. We did a tour of the labs up here. Sorry for those that couldn't make it. We will probably host another one. Happy our doors are open here. CableLabs were owned by the member community, so this is for you. And the other beautiful thing about SCTE is Expo is going to be here in Denver this year, and we'll walk through the benefits of membership. But a key benefit of membership is you can go to the Expo. You can go every day. You can go one day. You can go part of a day. So if you're here in Denver, which most of you in the Rocky Mountain chapter are, take advantage of it. Come down there, see the vendors that support this industry, support the technology. It's a great networking opportunity. So just want to remind everybody, mark your calendars for October for Expo. Okay. Here we go. All right. So for those of you that don't know the relationship between CableLabs, Kyrio, and SCTE, again, we're here in CableLabs offices, but we're co-located with Kyrio Labs, and we have some SCTE employees here as well. And it's a wonderful balance of the triangle where CableLabs is a member-owned organization, nonprofit, member-owned by the members, Comcast, Charter, other MSOs. They fund CableLabs, and they fund CableLabs efforts for research and development, investing in platforms and technologies. But because of the nature of being member-owned, all of the members have to agree as a board on initiatives that CableLabs will work on, and they cannot show favoritism towards anybody. So even though Comcast might be bigger than Mediacom, they get the same attention and weight in terms of where CableLabs invests. And as a result of that, there were members that needed specific development initiatives. There are manufacturers that need specific attention or want to do specific projects with CableLabs. So Kyrio was formed. So Kyrio is a fully owned entity of CableLabs. We call it a taxable entity. I don't like to say it's for profit, but it is a taxable entity. Any money that Kyrio makes goes back into the CableLabs ecosystem. So you as CableLabs members not only own CableLabs, you own Kyrio. And then 2 years ago, SCTE and CableLabs joined forces. And so SCTE is also a nonprofit organization, and it is for the benefit of all the CableLabs members. So that said, oh, I keep hitting the wrong button on this remote. What do we do at SCTE? And again, this is an SCTE event, but we're all one big happy family here, and I just want to remind people of that. But SCTE specifically provides educational services, certification. There's a standards arm of SCTE. We're really trying to rejuvenate that a bit. And through SCTE courses, certifications, et cetera, there's career advancement and networking opportunities. And then community outreach. I mean, the beauty of SCTE traditionally is we can bring members of the industry together. And so when we have chapter events, we have people from all MSOs, we have manufacturers, we can share best practices, we can conduct training sessions. So it's an industry organization. So it fit in real well with CableLabs, and we're trying to take that forward as one big happy family going forward. Part of that initiative is this year we've created the All Access program with SCTE. So those of you that may or may not be familiar with SCTE courses and training that you took through your organization, previously it was called All In Seats, and there was a specific number of seats allocated for each organization, each MSO, based upon their size. Well, now as part of CableLabs, every cable employee can sign up for SCTE. You can go on there, you can take any of the hundreds of courses, you can take certifications, you can register for the chapter. And as I said, once you're registered as an SCTE employee or SCTE member, you'll get free access to Expo. So it's a huge benefit. And like I said, we'd like to see as many people support it because it's really funded by the manufacturers themselves, right? They pay to exhibit there, and they pay to show their wares and to let the industry as a whole know the great things that they're working on. So again, it's a benefit that we want everybody to take advantage of. I talked a little bit about certifications. Some MSOs have career learning journeys and progressions, but the SCTE has its own certifications as well. So you can, if you're interested in a certain career path, whether you want to go from outside plant to inside plant to design engineering, I mean, you can go all the way to a DOCSIS engineering professional through SCTE certifications. And the certifications themselves, once you get through all the courseware and you are ready to take the test to be certified, that is an additional fee, but most of the MSO members will reimburse you for that. And the Rocky Mountain chapter takes that one step further and actually gives a stipend or a bonus to go for certifications as well. So I will say the Rocky Mountain, I've been to a lot of chapter events. The Rocky Mountain chapter is one of the strongest in the country. And this is another example of that. Also, people don't realize we're trying to get the word out, but we have collaboration with a college in Arizona, Rio Salado. And so for those coming in entry level, field techs, maintenance techs, you could take SCTE courses that will give you college credits towards an associate degree at Rio Salado. So a combination of SCTE courses, and we can get you more information on that, but a combination of SCTE courses with Rio Salado courses, and you come out with an associate degree in broadband telecommunications. So another benefit there. We also have third-party certifications like Cisco Network, CCNA, CompTIA, other third-party programs that are available through SCTE. And finally, you know, there's a lot of resources out there. There's the Rocky Mountain Chapter Facebook page, as well as LinkedIn, our website. Go out there, register to get updates on events like this, and just stay connected and spread the word about SCTE. Final reminder about Expo. I'd love to see you there. And then we want to thank our sponsors, which again, some of these events as well as the Expo couldn't happen through our sponsors. So partnerships with our big MSOs, as well as over the past few days, it would not have been possible with all the sponsors that you see here. So we thank you all for turning out for these events and your support. And with that, I'm going to turn it over to Doug Jones. Looked like it was out of focus there for a second, but Doug's the principal engineer with CableLabs, and for those of you that were not here, he's he's walked us through how hard he's been working on DOCSIS 4.0 and how much more he's got to go. So, he's got 30 years in cable. He's been on the operator side. He's been on the vendor side. He's been now here at CableLabs. So I think with 30 years, he started when he was about 10. So he's a smart guy that was on the fast track. And but no, Doug is a big supporter of the SCTE, and we're pleased to have him here today to talk about DOCSIS 4.0.
How do you have those slides? Switch which button you looking at?
The right. Yeah, I kept hitting the bottom and that goes out. So let me.
Well, I've got about 80 slides. Actually 45. And we can figure out how we want to roll. Anybody have to be home for dinner? Your wife doesn't want to see you. Brand will probably split. Chainsaw. There it is. So like I said, there's I think a number of slides, but we'll work through and give you an overview of technology. Magnetics, you guys were in the spec writing meetings in 2020, so you can quiz Paul on some things. Big on the horizon, and I'm going to go a little fast. If anybody wants to know anything, ask your question. But we coined this thing called 10G. It was 2019 CES. Nobody knew what it was. And then if you watch the Super Bowl this year, Comcast had a 10G add-on. So 10G is actually mainstream.
Let's just make sure.
And I should talk into the microphone.
We tested earlier. It does.
Do we have people on the bridge?
Yes, we do. We have 20 people on the bridge. So please use the
Outstanding.
microphone.
Yes. All right.
Still in like a preview mode. You see these gray boxes. There's some kind of weird mode.
There's something going on there. It's probably because I did it on a PowerPoint from Macintosh, and that happens to be a Windows machine.
Yeah.
So anything's possible.
I think those show up because of the screen sharing through whether it's WebEx or something else.
Show up.
That's the part of the screen.
Sometimes it helps if you pour water on your laptop. Or pour Coke. Get your Coke over here. Don't worry about it. The show must go on. We will endeavor to persevere. Damn the torpedoes, full speed ahead. 10G speed, low latency, security, reliability, the 4.0 specification, and 10G is not specific to DOCSIS, for instance. We also look at it when we look at passive optical networking. We look at it when we look at 4G and 5G mobile technologies, and even Wi-Fi, right? These are just some nice generic pillars that we try to really focus in on. And I be truthful, we in the DOCSIS 4.0 specifications, because this really is a DOCSIS discussion, we really did address all four of those pillars, if you will. Low latency is there, reliability, more instrumentation, speed. The speed is amazing. I started working on DOCSIS 1.0 in 1996, and it was 10 megabits symmetric, right? It was, and that was a big deal. And now we're hitting tens of gigabits per second on the coax. And then security, we really did give security a refresh in DOCSIS 4.0 specifications because really security hadn't changed much since about the year 2002. So about 20 years later, we put a way to roll the keys, for instance. But we did do a major upgrade on security, if you will. I'm really looking forward to testing the new security stuff. And I've got a slide on security as well. We'll talk about it. So speed, this is what everybody wants to talk about. It's all the press releases. Was at Anga Show last month. It'll be at Expo in October. And by the way, we hope you all join us at Expo in October. Should be a lot of fun. Hopefully not a snowstorm. It's a crapshoot. Speed is about spectrum on the coaxial cable. Allocate more spectrum and I can get you more speed. It's tougher to get more speed without allocating more spectrum, and we're doing that in DOCSIS 4.0 in a couple of interesting ways. In addition, operators reclaiming video QAMs and allocating that spectrum to broadband. And I know there's a couple operators in North America right now that are doing high split DOCSIS 3.1 with no video QAMs. They're doing all OFDM and DOCSIS broadband QAMs. And so they've already moved away from video, and they are lighting up the 3.1 spectrum as best they can, or all of it, with DOCSIS carriers. In 2006, right, we started with DOCSIS 3 technology, rolled out 4 bonded channels, and that was a big whoop-de-doo. It actually was a big deal. Let us go from, say, maybe 20 megabits in the downstream to 120 megabits. And the interesting thing, and this is actually true, in 2007, that's when Netflix started streaming. Who used to mail DVDs in Netflix? Yeah, I did too, up until about 2007. And it was that increase in the downstream speed because DSL couldn't match that. Couldn't match that at all. And PON was not anywhere in North America at that point, really. So we had RFOG, which is fiber to the home, but it's not PON. So that's what DOCSIS does. We increase the speed. We don't even know what the next apps are going to be, but they show up. And this was an interesting, this was actually now, it's going on a year ago that this came out. For the first time ever, more people watched streaming TV, and this is in, I believe, North America, the US, than they watched traditional cable TV. In other words, there were more eyeballs watching streaming services than there were, if you will, the old QAM set tops or DTAs. So I think people, yeah, I read into this, people are starting to become more comfortable with broadband offerings. We're doing everything over broadband now. Originally it was the web surfing, then it was telephone with voice over IP. Now even the mix of video viewing has gone towards streaming. And I know I have. No offense, Comcast. I canceled video service a couple years ago just to try this out. And it works. The only downside is I've got 5 apps, 5 GUIs, 5 user interfaces. I'm not sure I can handle it. But anyway, right? So, you know, people are streaming gobs. So we need capacity for this. So talking about speed, the next series of slides goes through the amount of capacity that's on the service group, if you will, the DOCSIS service group. What we've been using the last couple of years pre-pandemic, this is the number. It's like one OFDM channel, 32 QAMs in the downstream, the traditional sub-split 4 QAMs in the upstream. You know, actually, and this was what enabled with DOCSIS 3.1, the first gigabit downstream speed tiers. But we still only had a megabit, 100 megabits per second upstream on subsplit. I first entered the industry cable in 1993. It was on subsplit. Subsplits had a good ride. Now we're going to go through the work to change the split. Some operators are doing mid split. Some are going to go to high split. Some ultra high split. We'll see. Very good question when the first operator goes ultra high split. But that was the amount of capacity on the service group. This enabled streaming. It got us through the pandemic. So it's a lot of capacity, right? Everybody stayed home for a year and a half, watched Netflix, and did all their Zoom, WebEx, GoToMeeting, Teams calls, et cetera, on this kind of capacity. Now, well, okay, 2.7 aggregate, we went through that. I'm going to blow ahead here. Now we're going to what operators are moving to, not all of them, but most North American operators in Europe. Europe has been here since 2014, you told us, Paul, high split.
It's following split equipment.
Yeah. If you go to high split, and by the way, we also cleared some of the downstream spectrum, or you put in high split amplifiers. Now your 750 plant goes to 1 gigahertz. You got room for another downstream OFDM channel. This is what the demo I was showing with Paul's amplifiers in the optical lab. It'll do 4.7 gig down and 1.7 gigabits upstream. And this is where operators are going to now. In North America, Europe is, already there. I'm not sure they're offering the full 2.0 FDM channels or not, but you can see we're adding a couple gigabits in the downstream, and it's the upstream that really changes. If anything, the pinch point was the sub-split upstream, 5 to 42 megahertz. Now going to high split, the upstream goes to 204 megahertz, 2 full OFDMA channels, 1.7 gigabits per second. So a lot of capacity there, but that's still DOCSIS 3.1. We haven't got the 4.0 yet. So, this is actually the speed test I was showing you in the lab as well. With that modem, I'm going to skip past that and go right to DOCSIS 4.0 now. What are we going to get with 4.0? Well, it's already been demonstrating. Well, we get what I call 16 gigabits per second aggregate. And you can split that up in different ways because there's multiple splits now on the coaxial cable. The demos we did here last April at the 10G showcase at CableLabs, these were the numbers that were shown. 10 gigabits per second in the downstream, 6 gigabits per second in the upstream. This is with the coax operating at a 684 megahertz upstream split. So now we're at 16 gigabits per second aggregate. This ought to be more wide. Well, this will actually start being rolled out next year. All the pieces should come together next year. Already in the labs, the modems and CMTSs are there. The amplifiers are there. SCTE, and I got a little bit on this at the end, but SCTE has got multiple working groups going with DOCSIS 4.0 installs, network reliability, just the SCTE working groups. If you want to join one, let me know and I'll tell you which they are. And actually they're on the later slide, but a lot of work going on to prepare for 4.0. And I've got a list here, some of the splits. If you got a high split duplex filter, 15 down, 1.5 up. This was demonstrated at ANGA 2 or 3 weeks ago. Vodafone Ziggo did a press release with Liberty, with Technetics, where they showed 1.5, actually a little bit more than 1.5 gigabits per second in the downstream. 15, I'm sorry, 15. Think about it, 15 gigabits per second. I go back to DOCSIS 1.0 again, actually. It was 40 meg down, 10 meg up was DOCSIS 1.0. And now I'm looking at this, right? It's phenomenal. And what are we going to do with this capacity? Or with the extended spectrum version of DOCSIS 4.0, or even with FDX, you can kind of allocate the spectrum in different ways. So you can do 13 down, 3 up, 12 down, 4 up. The operators have some choices here. We'll see. The operators that I know rolling out 4.0 to start are going to do high split, 1.8 gigahertz, and we'll get that 15 1.5 number. And we'll see. And again, that 1.5 is up from 100 megabits. So we're 15xing the upstream capacity. And we'll see where that goes. So that's the DOCSIS 4.0 speed story. And it's the story that gets everybody's attention, lots of press releases. And just wait till Expo again this fall. This stuff is going to be all over the show floor. It was all over the floor at ANGA, I understand. I did not attend ANGA, which is in Cologne, Germany. It's a nice trip if you can get your guys to send you there. I keep budgeting for it, but no one will let me go. But I will go to Expo, and this stuff will be all over the show floor. It's really, 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 and with the amplifiers, with all the taps, the passives, the actives, the fiber nodes. And that's really, and something unsaid, but should be said, it's the same coaxial cable that's out there right now. We are, again, repurposing the same coaxial cable. I personally have gone out to various operator sites, looked at coax that was constructed in the 1980s, still meets their data sheets, still meets spec. So even coax that was built that long ago, and probably even longer, can support these kind of speeds. And that's kind of the point of continuing doing advanced DOCSIS. You don't need to overbuild yourself with fiber. Sure, do fiber in greenfield, please. But where the coax exists, we believe there's very competitive speed offerings here. And then this just shows how things have progressed. 2 dials of 3.1 pre-pandemic, where we're going with high split, and then how we're going to spin the needle with DOCSIS 4.0. And actually with 4.0, like I said, I think it's going to start off as 15 down, 1.5 up, which means operators could actually do a 10 gigabit downstream speed tier. By the way, 10 gig PON is actually only 8.5 gigabits symmetric because of the forward error correction overhead. They don't count forward error correction. All my numbers take forward error correction into account, but PON doesn't. So a 10 gig PON can only do 8 gig down. You see those announcements out there already. Cable with DOCSIS 4.0 will be able to announce a downstream speed tier faster than fiber to the home with 10 gig PON. So I really think we're well positioned. And that's why you're seeing all these webinars pop up about 25 gig PON and 50 gig PON. Because we kicked them again. But anyway, and I love PON. Don't get me wrong. I'm just saying coax is in the ground from the 1980s. It still meets spec. You can do this stuff on the coax that's out there today. Really, really, really interesting. Oh, the 10G challenge. So what are people going to do with this? I don't know. I like to tell people I'm a plumber. I build big pipes, really big pipes. And what people are going to do with it, I don't know. But CableLabs did sponsor something last year called the 10G challenge. And what was that? Well, we're trying to figure out what apps people might come up with if they had all that kind of capacity. There was 4 categories: live, work, learn, play. We gave real prize money for people to submit their ideas, $100,000, $50,000, $10,000, et cetera, et cetera, et cetera. The results were announced at last year's Expo. Where was it last? Where the hell were we last year?
Philly.
Philly. Yeah. And, guess what? Not a whole lot. It was about streaming really large files or high resolution video and uploading and downloading really big files. Those were the use cases really that it came out with it. So it's all up there. You can go look at the YouTube from last year's Expo in Philly about the presentations and this, that, and the other. But, we're trying to beat the bushes. We're providing these big pipes now. What are people going to do with it? And we'll see. Just like when we rolled out DOCSIS 3.0 in 2006, in 2007, Netflix started streaming. We'll see what starts happening in 2025 when DOCSIS 4.0 starts showing up out there. I really don't know, but I'm really excited to build these big pipes. I'll pause there a moment. That's the speed story. The speed story, it's huge amounts of speed, a capacity, I should say, that operators can carve up into new speed tiers, that application developers can do new things with. I don't know what it's going to be. I'm not a gamer, blah, blah, blah. Questions, comments about speed? 16 gigabits per second aggregate on the coax that's already constructed out there today. Just replace the actives and passives, but you don't have to replace the coax. You don't have to dig up streets, don't have to dig up backyards, replant shrubberies, and all that stuff that goes with a major kind of construction project like that. All right, so 4.0 technology, there's various network paths. There's the extended spectrum DOCSIS, also officially known as FDD, frequency division duplex DOCSIS, but everybody calls it ESD, so I'm going to call it ESD. And then there's the full duplex DOCSIS technology known as FDX, which Comcast is a proponent of, and we will go into some details of that. Low latency, let's talk about that briefly. So low latency was officially introduced in the DOCSIS 3.1 specifications. There's a big component actually on the modem itself. There's all these new acronyms: aggregate service flows, dual queues, coupled queues with active queue management, queue protection, yada, yada, yada. There's a lot of stuff going on under the covers. The bottom line is, before this came in, the average latency, if you will, on a DOCSIS connection, I want to send a packet, I hit return, and when does that packet finally get up to the internet? 20 to 50 milliseconds, which actually isn't a lot. If you're a gamer, it's a lot. So with this low latency technology, we can get that latency down from 20 to 50 to under 10, consistently under 10 milliseconds. And the intent is, it's a really cool technology. The intent is, can the cable operators make a business out of it? Can they find out a way to offer a low latency tier? Obviously, gaming always comes up. We've been chasing the gaming industry for a while. 2010, it's been over a decade, going on 15 years. We've been chasing the gaming industry because they don't do a lot of bandwidth, believe it or not, on their games, but they expect low latency, the fast twitch games and such like that. So all this stuff is there. It was in 3.1. We're carrying it forward into 4.0. And it's very interesting. Oh, I've got an old interrupt there the week of 24th of April. So it happened. It was good. Security advances. I told you I'd do a quick slide on security. So we've created something now we call Baseline Privacy Interface Plus version 2, BPI plus V2. The old security is known as BPI. Now we call it BPI V1. But V2 adds a couple things. One, you got to transition from V1 to V2. So V2, 4.0 includes something we call TOFU, Trust on First Use. You can roll out DOCSIS 4.0 with BPI plus V1. No changes to any operations today. Keep running V1. It runs just the way you're used to it, and transition to V2 when you want to. But if you roll it out with V1, we call it Trust on First Use. You trust that it's V1 and you transition to V2. We made it very operationally friendly for the cable operators. Mutual authentication. Everybody's working on RPDs or RMDs, the new CMTSs. So today with BPI, the CMTS actually authenticates the modem, because there actually are bad people out there that clone modems, try to steal service. I've heard that. How many are on your network right now?
Not as many as there used to be.
As many as there used to be. God, you guys are good at answers. Nice deflection. So the network would authenticate the modem to make sure it was an authentic modem. But now the modem actually authenticates the CMTS, because part of that CMTS is in the outside plant. It's in your fiber node. And even I can think of a crazy case where you got an RPD hanging out in Dave's neighborhood. I come along and swap it with my RMD, and all of a sudden I'm getting all the traffic, because all the modems are going to register. They're going to go offline. They're going to come right back up and register, and I'm going to see everybody's traffic. It's actually not a hard thing to do. So we made the modem now authenticate the network. So mutual authentication. And by the way, it's no big deal. Mobile phones do this, have been doing this for years, because your mobile cell towers are outdoors too. They can be hijacked or whatever. So we added mutual authentication. See, a standard method to SSH into the cable modem. There was never a standard method to access, like root level access into the cable modem. Some suppliers provided their own methods, which may or may not have been secure. So this time we actually added a secure method for, say, your tier 3, tier 4 support people to SSH into the modem, get Linux level access, and see what's going on in that modem. So that's actually a good useful feature. Number 4, we added a method for the CMTS to real-time check the cable modem certificate using something called OCSP, Online Certificate Status Protocol, IETF standard stuff. Large hyperscalers use this protocol to check certificates. And if an operator wants to, now every time a modem boots, your CMTS can go, is this a real certificate or not? Or has it been, what's it called, revoked? Has this certificate been revoked? And it doesn't say why it was revoked, but you can find out. So anyway, there's a way to real-time check now the modems coming onto your network. And then we changed the key exchange algorithms a bit, so the keys can exchange more often, something called ephemeral key exchange. It means it can come and go. I don't even know what it means. Dave, what does it mean?
I don't know.
Okay. Yeah, it's that secure. It's that secure.
Nobody knows.
And perfect forward. See, it's something the security folks talk about a lot. They're very excited about number 5. So we really did advance DOCSIS 4.0 security. It's the network with all this capacity, and we're going to all get more subs, and we want to make sure it stays secure going forward for the next 20 years. Reliability. The modems expose more data, so we can do proactive network maintenance, PNM. We can do profile management applications, PMA, to manage throughput better. We even made the amplifiers provide data, a method for the amplifiers now to provide data. This was the most recent SCTE standard. SCTE 283 was just published last week, I think. So now there's an information model for line amplifiers. Some suppliers have been doing this for a while. You need a transponder in the modem, and then you can actually sit at your desk and get all kinds of data statistics out of the amplifier without sending a tech to park the truck, put the cones out, get in the bucket, raise the bucket, open the amplifier housing, let the ingress in, take, plug and take a measure. Now it can all be done from a desktop. We're going to see how this gets adopted, but we should be able to make the network even more reliability with technologies like this. And believe me, there are some really smart people. There's none in this room, Dave, that are working on these things, coming up with new algorithms, new products, new ways to use all this data. And it is going to make the network more reliable. Less actual fingers in the network, changing pads and EQs and taking off tap phase. Less fingers in the network should make a more reliable network. Okay, so we've gone through those 4 pillars: speed, security, reliability, low latency. Any questions on those 4 pillars? I'm just going to keep blowing through here. I can't look at the chat. I don't even know if there is a chat, so I'll leave it at that. So the physical layer for DOCSIS 4.0 is really, well, it's not the same. It is based on the 3.1 technology, so it's more OFDMA, OFDM channels. Still supports the single carrier QAM channels. Still supports up to 4K QAM. Although we just had a recent demo that was 16K QAM. That was the one at ANGA last month. Very interesting. So it's that same physical layer. It's just more of it. So you need more spectrum. That goes back to the speed point earlier on. Give me more spectrum and I can give you more speed, more capacity out of this. We're actually, for those really into it, we're close enough to Shannon's limit on the coaxial cable. I don't think we're going to get MER much better. You tell me, are we going to get, another 3 dB of MER improvement?
44 at 1.8 gig.
I'll take 44 at 1.8. When will I get?
Where you can do 16K bump.
Yeah. I mean, do I need 3 more dB or should I look at more spectrum? Now, if you look at Shannon's theorem,
16K bump.
I do if it's reliable or if I have a PMA app that can keep it operational. I look forward. That was the first thing when I read that. It wasn't the first thing, but it's about the third thing I said, oh crap, can I measure 16K QAM? What does that constellation look like? Do I need a 85-inch TV to even see that constellation? There's
quite a lot of discussion about the loading network, but that's another story.
Well, and I ran into that, I don't know, 5 years ago when I tried to buy an OFDM amplifier or something that would amplify OFDM on coax. Everything I bought was it didn't work. So there's some interesting stuff in there with all this bit loading and anyway. It's really the same physical layer as 3.1, just more of it, at least in the case of ESD. With FDX, we're actually overlapping spectrum. So there's some other technologies to make that work. But learn OFDM, learn OFDMA, and we'll keep QAM around for a while longer, but really learn the OFDM and OFDMA technology. So there's these 2 paths we've talked about, ESD and FDX. Oh, I should change that to 16 gigabits aggregate. So the 2 network paths, these are something operators have to choose, have to decide which way they're going to go right now. ESD, extended spectrum DOCSIS, which is, quote, the traditional spectrum allocation, has a duplex filter, separate upstream, separate downstream. The coax operates to 1.8 gigahertz, which is brand new. Most of us are still operating subsplit 750 plant, and we'll have a diagram going up to 1.8 gigahertz is another gigahertz of spectrum to operate on, which is really more spectrum for the OFDM, OFDMA channels. Nobody's asking to add more QAM channels. It's all going to be the wider OFDM and OFDMA channels. All this stuff was on display last year's Expo, prototypes. This year, it should be all over the show floor with actual DOCSIS 4.0 modems and CMTSs. Doing really cool stuff here. So that's ESD story. For example, Charter is pursuing the ESD route. Charter, Cox, the new Rogers, which includes Shaw. The full duplex side, FDX, is being pursued by Comcast. There, the spectrum operates to the current 1.2 gigahertz, or you can even operate at the 1 gigahertz if you have 1 gigahertz passives on the plant. In full duplex operation, and this takes a little bit of thinking to actually wrap your head around it, but the upstream and the downstream operate in the same spectrum at the same time, which is really revolutionary. It requires some new technologies, as I talked about. We'll get to them. But the upstream and the downstream overlap. There's not a duplex filter separating them. And we've been working on this for a number of years. There is work towards an amplifier. That amplifier should be on the show floor this year. Actually, yes, you should be giving a presentation on this, Mr. Broadhurst, of the possibilities here. But there will be a full duplex amplifier. Originally, FDX was specified for node plus 0 plant. Actually, that's what's in the spec. But since then, an FDX amplifier has been in the works. It was a demo. Well, there was one on a wall at last year's Expo. There was one on a wall on one supplier's booth. And if you look around in Denver at Expo this year, I'm sure you'll see it again, maybe in a couple places. So those are the two, if you will, paths for DOCSIS 4.0. And here's a look at the spectrum. It's interesting too, right? They both support the same amount of spectrum, upstream spectrum and downstream spectrum total. In the ESD case, the spectrum is separated by a duplex filter, just like it is today. No big deal. With the FDX, that spectrum is actually overlapped from 108 megahertz to 684 megahertz. There's 584 megahertz of overlap spectrum. And coax plant has never operated that way before, but we've got some of the smartest people in the industry and best looking people in the industry working on it at Comcast. And it's interesting. We saw it work last year at the 10G showcase. So there's these two ways to run your plant. Part of the issue is, right, do you want to only operate at the 1.2? Do you want to change out your taps? FDX could be for you. If you're willing to change out the actives and the passives, then ESD might be for you. We're going to see how this stuff plays out over the next, well, we should know by next year's Expo. There should be tons of press releases. And next year is in Atlanta. I believe it is in Atlanta next year. Yep. So back in Midtown. So just thinking ahead. After that, it's in Washington, D.C. because it's an election year, I think. But anyway, 4.0 pass. So extended spectrum. I'm going to go through them both, ESD and FDX. ESD, a way to think about it, is what the industry has been doing from the beginning, ever since we activated the return path. We've been extending the spectrum as amplifier technology improves. And I could go through the generate. Actually, I would like a presentation, Paul, on the generation of actives. There was the first doublers were something, then the next ones were gallium nitride, then gallium arsenide.
Gallium nitride.
Yeah, and first they were called just semiconductor amplifiers. Then
They're all
GaN.
semiconductors. It's just that they're high electron mobility.
Yep.
Transistors.
And a whole presentation on that evolution of the gain blocks as we go from 220 plant to 330 to 450 to 5.
You can go back to tubes as well.
I would love to do this presentation with you, just from a historical perspective. I would love to do it. Not that you were around when there was 330 plant, but
I have upgraded to 250 meg.
250. There you go. Questions? Yeah. So anyway, ESD, don't get hung up on a new acronym, extended spectrum, right? We've been extending the spectrum since the 1960s. So just with higher end amplifiers that can amplify more spectrum, duplex filter in between, it's just what we've been doing. Oh yeah, now we're at 2016 and then we go to 2024. Yeah, that's right. 2024, we went to 1.2 gigahertz. Then we're going to go to 1.8 gigahertz. It's just what we've been doing as an industry. So, and here's a quick look, right? When I started in the industry, 1993, subsplit 750 was state of the art with an activated return path. And now I don't know what that is, 30, I guess it is 30 years later. Dang it. 30 years later, we're adding an additional gigahertz of spectrum. We're actually doubling the amount of spectrum that's active on the coaxial cable. Again, same coax that was built in the 1980s can do this. Same coax that was there in the 1993 when I started can do this. It's just better electronics on all around that coax, but that same coax is capable of this. And with, we talked the earliest on, if you want more speed, give me more spectrum. You want more speed, give me more spectrum. And that's what we're doing here. And it's dedicated, not to more HD channels, but to broadband, which people can get to HD channels if they want to, but it's there you go. And like I said, there's various ways to split up that spectrum, 1.8 gigahertz, you do a high split, there's a 300 megahertz, 396, 492 megahertz split, and the 684. Of course, you have more upstream, you get less downstream, and the operators have to choose really from a business perspective, where do they want to apply the spectrum? What speed tiers do they want to offer? What's the competitive picture? All these questions, capacity as well. But the option, operators have more options for splits on the coax with ESD. That's ESD. I mean, it's just more of what we've been doing. We're going out to 1.8 gigahertz now. Thank you, Paul. FDX, we'll talk about that. The coax continues to operate at 1.2 gigahertz, which is where it can operate today. All the there's plenty of 1.2 passes, 1.8, 1.2 amplifiers are everywhere now. Some are better than others, but some are smarter than others. The thing with full duplex is this overlapping spectrum. I mean, you got a piece of coax and you're sending upstream and downstream at the same time in the same spectrum. And we haven't done it before. But it also allows the flexible splits. That overlapping area, sometimes it can be more upstream, sometimes it can be more downstream. And that's all managed by the CMTS, if you will. How that upstream, and it can be managed in more real time, right? ESD, you got a duplex filter, and that duplex filter is there until you change that duplex filter. And that means changing in every active along the way, every node, et cetera, et cetera, et cetera. So the promise of FDX is I can make those changes in upstream and downstream actually on the fly, right? That's the intent of the specification, and these changes can be made on the fly. It's in blocks of 96 megahertz, and it can all be managed by the CMTS based on what kind of demand that CMTS is seeing. So there's more moving parts here. You got the overlapping spectrum, which is new, and now you got managing the splits, almost in real time, which is new. And that's some of the new technology which we're working on here.
What do you call it, a head end?
Yeah, I'm not exactly sure why I did that. I was presenting to a group that wasn't cable. That's how that term wound its way into the presentation. This is one of those presentations. This is the 8th time I've given it. Some people know what I'm talking about. Most people, some people didn't know what I talk about. So it's been an interesting development of a presentation. So the FDX band we talked about is between 108 and 684 megahertz. So this is what your spectrum maps look like, right? There's no delineated upstream spectrum and downstream spectrum. The 5 to 85 is upstream. You got your legacy upstream from 5 to 85. You got downstream only from 804 up to 1.2. In between, you've got this full duplex spectrum that can be up or down at the same time. For different groups of modems, and it's a new concept. There is this transition band between 684 and 804. Call it a duplex filter, if you will, separating the FDX band from the downstream band. No DOCSIS in there, but the fiber node, a fiber node could put other things in that. For instance, that's 120 megahertz of spectrum in the US, that'd be 20 video quams. And this has been in some Expo papers. I think I'm pretty sure I stole this from Comcast. So Comcast has actually done a lot of nice Expo papers on how to transition to this, how to use it, et cetera, et cetera, et cetera. So I still haven't seen it operate in my lab, but it should be this year. So what do we got here? Oh, we talked about groups of modems. So when you think about full duplex, you got to think about the view from different places in the network as well. There's a fiber node view, where at the fiber node, the spectrum is actually full duplex up and down at the same time. And then there's groups of modems view, where the modems think, okay, this spectrum is up, this spectrum is down. But for different groups of modems, they can have different amounts of up and down spectrum in that FDX band. That's what FDX allows. Different groups of modems can have different amounts of up and down spectrum, and it's dynamic. Again, the CMTS can manage this based on the demand that it sees. And that downstream at the very end there, that should be blue. Why do I have the green and blue back? Anyway, but I digress. It's just a color thing. And we talked about two new technologies that really make full duplex work. And I stole these at the very bottom of the slide. There was a paper. Geez, what year was that?
2019.
Yes, there it is, and it's in the link. 2019 paper, Dr. Rob Howell at Comcast discusses these new technologies, and they're out of the spec, but Rob gives a good method or introduction or description of how they work. The two new technologies are echo cancellation, which is needed when you're doing up and down on the same spectrum, is echo cancellation. Echo cancellation itself is not a new technology. It's been around since the Bell system, actually. Telephones use echo cancelers. What's new for echo cancellation and DOCSIS is the amount of spectrum that overlaps, this 584 megahertz of spectrum. So echo cancellation needed to be included. And then number two is sounding. We talked about groups of modems have different amounts of up and down. Well, it's sounding, the process of sounding that identifies which modems are in which groups, which can have their own up and down amounts of spectrum. And however many groups there are, the CMTS has to manage those groups, has to identify those groups, has to manage those groups. So these are really the two new technologies that make FDX work. And this is what's being worked out right now. These are, if you will, there's technology here. There's also algorithms, a lot of software making this stuff work. And that's being worked out. So what's echo cancellation? Since up and down is in the same spectrum at the node, any echoes or reflections from the downstream at the node come back into that upstream spectrum. This happens today. The difference today is that up and down is separated by a duplex filter, so it's not a problem. But with FDX, there is no duplex filter in the fiber node. The up and down overlap. So anything, the downstream is high power, and it's going to echo off the connector, the pin connector at the node. It's going to echo off the first tap in the node. There's structural echoes off of the coaxial cable, and all that's going to come back and hit the upstream. So the node implements echo cancellation. The good thing is, right, the node transmits the downstream, so it knows what the downstream is. And when those echoes come back to the upstream, the node can subtract out those echoes because it knows what it transmitted. So it knows what the echoes look like. It subtracts them out. The upstream is low power, right? You're receiving somewhere between 0 and maybe 8 dBmV, where you're transmitting in the 40s or 50s. You can imagine how an echo could come back and wipe out that upstream. But anyway, echo cancellation takes care of it in the fiber node. Very interesting technology. Echo cancellation is straightforward. In the node, the transmitter knows what it's sending, goes to the coax, and then it also provides a copy of that signal to the echo canceller, which subtracts it out of the upstream. And it's going to be time shifted, it's going to be amplitude shifted, but smart circuitry can find it, subtract out those echoes, and you recover the upstream signal. And this allows us to share the up and down spectrum. The process of sounding is what identifies which modems can be up and down. This is really about isolation, RF isolation, the amount of loss between groups of modems on the cable plant. As it turns out, modems that are generally grouped on taps can be in the same group. When one's transmitting, they share the up and down spectrum. Modems that are in different groups, and the high value taps could be different groups. Towards the end of the run where you got lower value taps, there's less isolation because there are lower value taps. They might be put into the same group, but the CMTS manages this. It asks modems to transmit while these other modems listen. If the modems hear the transmissions, is it high enough, low enough that modem could receive at the same time as other modems are transmitting? It's algorithmic, but it's needed, and it makes full duplex work. Skip through that. And that's really DOCSIS, right? There's the 4 pillars of 10G. There's the 2 flavors of DOCSIS 4.0. And there's all these SCTE working groups that are involved with it. The data standards subcommittee does the data standards, the DOCSIS standards, the network operations subcommittee, NOS, does all the tools like PNM. Network service and reliability is under NOS, PNM obviously under NOS. The 3 gigahertz IPS interface practices subcommittee does specs for pieces of gear. They did 3 gigahertz actives and passives. That's available. Smart amplifiers. They did a 1.8 gigahertz amplifier standard. You know, the SCTE has been all over this stuff. The SCTE has been all over this stuff. There's standards available. There's working groups available to participate in. There's so many calls, I can't even make them all during a week. I give up, uncle. That's just because DOCSIS is getting so close to being ready to work on. Some of the new standards, SE 264 was 1.8 gigahertz hardline taps, actually in 3 gigahertz housings, back bodies. So you just do a faceplate change, maybe to go to 3 gigahertz. There's also a standard on the passives, the splitters, the DCs, power inserters. SCTE 273 is the gap standard done out of Charter. 3 gigahertz node dissipates 200 watts. You can put a lot of stuff into that. SCTE 279 was the 1.8 gigahertz amplifier standard. And then just this year, the SC 283, the information model for that 1.8 gigahertz amplifier came out. So just there's all kinds of working groups, multiple standards. DOCSIS 4.0, the industry is really working hard on it. And next year should be in the networks. Yep, I know. And there's online class. There's online D4O class already. If you want to take it, sign up. And thanks for being here. Can I take any questions? I kind of whipped through it. I know there's a lot of cool new technology here. The bottom line is the amount of capacity or speed you get with this stuff is wow. Wow, 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 wow. Same coax, more spectrum.
You said you're getting a 4.0 CMTS late this year?
Yes. The question is, we're getting a CableLabs will be getting a 4.0 CMTS late this year. Yes, that is our discussions with operators and suppliers. The modems are ahead right now. We can get modems in actually next month. We're holding an interop. It'll be announced on Monday. Breaking news. It'll be announced on Monday. In July, we're holding an interop of DOCSIS 4.0 modems and DOCSIS 3.1 CMTSs.